there is a problem that gave you a little bit of difficulty. Okay, so who's got one? Who was studying and has a question about something? What?
Box problem.
A box problem. We know for sure, thank you, Malcolm, we know for sure that there's going to be a box problem on the test. In fact, we know for sure there's going to be a problem on the test like every single problem on the review sheet. So that's why I want you to ask right now which ones you can't do. Because if you can't do it, you're going to miss it. It's on the exam. So yes, the box problem is on the exam. So we're going to have a piece of paper. We're going to cut the corners out. You know how we do. And the piece of paper is going to be, let's say, 20 by 17. And you're going to have to answer 3 questions about that. You're going to have to give the volume, you're going to have to give the domain, that's the equation for the volume. You're going to have to give the volume equation, you're going to have to give the domain, and then you're going to have to find either the size of the corners or the maximum volume. Those two come together, it's just which one you pick, you would call that. All right, so here comes our equation. Remember the equation for volume is length times width times height. So what is it going to be if the paper is 20 by 17? 17 minus 2x.
20 minus 2x.
20 minus 2x and x. Over and over again, kids forget the x. Over and over again, kids put 2x minus 17. That's ridiculous. The paper is 17, you're taking off 2 x's. It's got to be 17 minus 2x. Okay, that is it. There's the equation. Now, what's the domain? The domain is important because in a minute, we're going to go to our calculators, right? And the domain is going to give us x min and x max. The smallest x and the biggest x. So x is going to be between what? What's the smallest x?
0.
0, always 0. Obviously x can't be negative. 8.5. And where did we get the 8.5?
Half of the smallest.
The biggest x is always half the smallest dimension. Okay? James, can you take your hood off, please? Now, those things never change. I mean, the numbers change, but the concept is exactly the same every time. So now we're going to go to our calculator, and we're going to actually find the answer to the question, which could be what's the size of the corners, or it could be what's the maximum volume. So we go to y equals, we're going to put this equation in, and I already have one in because I did one yesterday, but I have to change it, obviously, because I have new numbers. And then I'm going to change my window. So this is x min always. This is x max always. What's y min? 0. Y min is always 0 because volume can't be negative. What do I do about y max? Yes. I'm going to try 200. We'll just see what happens. Whoops. 200 isn't big enough. How do I know? I can't see the top of the hill, right? It goes off. I get a picture that looks like this, right? So I just go back into my window and I'm going to make it like 500 because I'm way small. Ooh, 500 is barely big enough, but it is big enough. So now I see my hill. When I graph that equation, x min, x max, y min is always 0, and I guessed a y max of 500. Got my picture. So now I second calc, go down to maximum, and I got 3.05. So when I got the maximum, it gave me a point. It was 3.05 and 462.11. That's what I got when I did my maximum on my calculator. So if the question says, and you just have to read it, if it says find the size of the corners, then that would be your X value, right? Those are the corners, so that would be 3.05 inches. If it said, what is the maximum volume, that would be the 462.11, and that would be cubic inches, because volume was the Y you put in, right? Volume was your Y. Now, what will be different on the test? That won't be a 20, and that won't be a 17. But other than that, you're going to do everything exactly the same, right? Okay. Who else has something that you're not sure about as you flip through your papers? James?
You go through combining like two logs.
Solving an equation, you
Yeah.
mean? So there are two kinds of equations that we could experience like that. One would be something like this. So that would be one kind. And then another kind would look exactly the same over here. It would look like that on that side. So we've got multiple logarithms. In this problem, they're all on just one side. But it really doesn't matter. Both of these are going to start exactly the same way because we can't have two logarithms on one side, right? So what are we going to do? Combine them. And when we combine them, there's still a log. There's still a logarithm, but there's only one logarithm. And somehow we have to put the x plus 3 and the 4 together. How do they go together? As a multiply. So that would be 4x plus 12. Right? So 5 to the second equals 4x plus 12. When there's only one logarithm, we loop-de-loo it. One logarithm means loop-de-loo. So 5 to the second equals 4x plus 2. So 25, or 4x plus 12, I mean, 4x plus 12. So 13 equals 4x, so that one would be 13/4. Is that okay with everybody, that top one? Now the second one is going to start exactly the same way because you have these two that have to go together. So you're going to start with exactly the same first step. But if you have a logarithm on both sides, you do not loop-de-loo. You only loop-de-loo when you have one logarithm. If you have one on both sides, they just disappear. So 4x plus 12 equals 2. And 4x equals negative 10, and x equals, oh, what is that? Negative 2.5, negative 5/2, negative 2.5. Now, logarithmic equations can have extraneous roots. If I put this back into the original problem, this was the original problem, negative 2.5. This quantity will still be positive, won't it? So that's a fine answer. That's the answer. It's not extraneous. This can never be negative. The quantity can never be negative, but it's not. So we're okay. So James Wayne, is that all right? You see what's going on? Now I do want to throw out another one because we just talked about that. And if I'm reading your body language, you get that. That's not an issue. So let me give you another equation. This is exactly the same thing. This is a logarithmic equation. How many logarithms are in this equation? And when there's just one, what do? Loop-de-loo. What's the base?
E.
So the answer to this problem is e to the fourth. It's that easy. Okay? Don't make it any harder than that. If there is one logarithm, you loop-de-loo. Okay? All right, what else do we have? Anything else, Marita?
On review 2, number 3, it says find the y-intercept of, and it's like y equals 80 over.
Yeah, so there are several, I think like 2 or 3 or 4 problems where you have to find the y-intercept. So they can be all kinds of problems. Any equation, you can find the y-intercept for unless it's a vertical line. So like something like this. Or something like this. Or something like this. Any of those, or let me give you one more. Any of these, we can find the y-intercept for. It doesn't make any difference what the equation looks like. If you are finding a y-intercept, that means you are finding the point where we cross the y-axis, which automatically means your x-coordinate is 0. To find a y-intercept of any equation, I mean, even something like this. To find the y-intercept, you let x be 0. Period. Evan, to find the y-intercept, we let x be 0. So, if I let x be 0 in this top equation, my y-intercept will be, let's see, that would be 16 times -3, -48. If I let my y-intercept be 0 in this one, what's 2 to the 0th? 1. So this is 18 over 4, or 9/2. So my y-intercept is the point 0 9/2. If I let x be 0 here, -4. If I let x be 0 here, -3/4. It doesn't matter what the equation looks like. If you want a y-intercept, you're going to let x be 0. Period.
Do we write it like the answer 0,
If you're writing it, yes. It's a multiple choice question, so they may be written as ordered pairs or just numbers. All right, who else? James Wayne?
You do a simplified problem where it's the number is a fraction and so is the
Exponent?
The exponent, yeah.
So the base is a fraction and so is the exponent?
Yeah.
So we're simplifying something like 8/27 to the -2/3. Like that?
Yeah.
So, first of all, fraction or no fraction, anytime you have a negative exponent, the first thing you want to do is flip it, right? Malcolm, you with me?
Yeah.
So when I have a negative exponent, I'm going to flip it. So I'm going to make this 27/8 to the 2/3 power. When I flip it, this is what flips. All that happens to the exponent, it becomes positive. Never flip an exponent. This flips. Now, the exponent is a fraction. And whenever the exponent is a fraction, you have a radical. And the radical, this tells you which root to take, and this tells you which power to take. So we're going to take the cube root of 27/8, and then we're going to square it. So the cube root of 27 is 3. The cube root of 8 is 2. Now I'm going to square that. So 3 squared is 9, and 2 squared is 4. Now the problem looks pretty simple. There's several steps, so be organized, but you can get that. You can do that. All right, what else?
Doing the inverse problem.
Huh?
Finding the inverse.
Inverse. To find the inverse, we're just going to do basic, simple ones. It won't be anything complicated. So it'll say something like f of x equals 3x minus 5 over 7. Find f inverse. Remember, that notation means f inverse. So it might say find the inverse using the words, but it might also use that symbol. That means find the inverse. Okay, so what do?
Oh.
There's a problem. Yeah, we're gonna think of this as y, right? And then we're gonna switch the variables. So x equals 3y minus 5 over 7.
Yep.
Right? Now, solve for y. So we'll multiply by 7. Right? Add 5. And divide it all by 3. So that is the inverse.
You know when we find the vertex as well.
Find the vertex?
Yeah.
Okay, that's a different problem than this. So we're good on that, finding the inverse? Okay, so finding the vertex of a parabola. Well, the equation of the parabola can look a couple of different ways. It can look like this, or it can look like this. Now, these are two different parabolas. These are not the same at all. These are two different parabolas. But parabolas can look like that or like that. I recognize parabolas because in whatever form they are, they're x squareds, right? So that's an x squared equation if I boiled it out, and this is clearly an x squared equation. Those are parabolas. If the equation happens to be in this form, then the vertex is a no-brainer. I know that this parabola has been shifted 1 unit to the left and 4 units down. So if I take it 1 unit left and 4 units down, isn't its vertex at -1, -4? That's pretty basic. If, however, the parabola is like this, I can still find the vertex, but it's not quite that easy. Now I'll use my axis of symmetry formula, which is x equals -b over 2a. So -b over 2a would be 1. Right? That is not the vertex. That is the x coordinate of the vertex. The vertex is a point. The formula gives you the x value. So then how do we find the y value? Plug it back in. So we have 5 times 1 squared minus 10 plus 3 -2. So that vertex would be at -2. 1 comma -2. All right. While we're talking about this, there is also a question that says something like, consider the base curve, maybe it's this, okay? Right, that's one of your BFFs. write the equation that represents a move, a translation, or a movement 3 units right, a vertical stretch of 2, reflection across x-axis, and 2 units down. So write the equation, starting with your basic old absolute value v. What would the equation look like that did all of these things to that equation? Well, first of all, how do you move it 3 units to the right? What? X minus 3. So the first thing you're going to do is inside the absolute value, you're going to have x minus 3. That moves you 3 units to the right.
And
Now, a vertical stretch of 2. How do we stretch vertically? With a times, it's a times. Put a coefficient right out here in front. Right out in front of the problem. How do we flip it?
-2.
Make this number negative. That flips you over. Think about your parabolas. When you put a negative in front of the x squared, doesn't that turn it upside down? Same concept. Now 2 units down would take this down to okay. We did the exam yesterday in 1 hour and 2 minutes. And that's with me talking and answering questions and stuff. So time should not be a factor. So there's absolutely no need to rush. You can go through and do everything step by step by step to make sure you get it right.
Are you going to be in here during flex today?
Mm-hmm. I'm in here during flex every day, Emma. How many days have you come during flex, Emma?
None.
None! We can't just cram it all in at the last minute, but yes, I will be here during flex. All right, what else? What else do we have? James Wayne?
To do write the exponential function containing like certain points.
So we've done like 12 million gazillion of these, but we're going to do one more. We're going to write the equation of the exponential function. Is this on the review sheet?
I'm going off of past quizzes.
Okay, yeah, you want to go off the review sheet. I don't know that that's on the review sheet. I'll go ahead and do one, but I don't recall that being on the review sheet. And what did I tell you? If it's not on the review sheet,
It's not on the
it's
slide.
not on the exam. He wants to write an exponential function. So this would be 3 comma 3/8. Alright, so we want to write an exponential function, which means y equals a times b to the x. I cannot stress enough how important it is. I mean, looking back at all your old quizzes and all that stuff is awesome, awesome, awesome. But that exam review guide is golden. That's where we should really be focusing our energies. Well, anyhow, we know that a is 3.
Yes.
Because a is always the y-intercept, the initial value. This is y-intercept, the initial value. So now I'm going to plug 3 in for the x and 3/8 in for the y. And I'm going to solve that. To solve that, the first thing I have to do is get rid of the 3. Now, obviously you think, oh, I'll divide by 3. That's a great idea. This is a fraction though. So instead of dividing by 3, maybe I'll multiply by 1/3. It's going to accomplish the same thing. But if I don't have a calculator, it's easier to do this. So 1/8 equals b cubed. And b equals 1/2. So my answer would be y equals 3 times 1/2 to the x. All right,
Look over PRs.
to find the possible rational roots. So we have some kind of function that looks like this. And we have to find the PRRs, which are the possible rational roots. PRRs. PRRs are always factors of the last. So factors of the last would be 5 and 1 over factors of the first, which are 2 and 1. Right? So what is that altogether? Well, just take 5 and put it over 2 and 1. So that would be 5 over 2 and 5 over 1. Then take 1 and put it over 2 and 1. So that would be 1/2 and 1. So those are the numbers that are the possible rational roots. Right?
Can we do the square root function and show the easier Yintercept?
So there's no guarantee that the one on the exam is going to be the square root function. You have 12 BFFs. So the square root function is one of them. I could just as easily ask questions about the absolute value, the squaring function, any of them. But if we take the square root function and we want to know the domain and the range, and what else do we want to know?
Asymptotes,
Asymptotes,
increase, decrease, arrows, and bounded.
increasing, decreasing, bounded. So we want to just answer some basic function questions about the square root function. Now, I like to look at the square root function. I know what all my BFFs look like because my teacher asked me to memorize the shapes. So that's the square root function. So I should be able to look at that graph and say what the domain is. What are the x's in that graph? X is greater than or equal to 0. That's exactly right. I'm going to go ahead and throw in another one here so we can answer the same questions with a different curve. Okay, so we'll answer the same questions. What's the domain here? What's the domain of this one? No, anything greater than 0. It goes down here, so it goes all the way to 0. The difference is this one can't equal 0 because this is like an asymptote, but here it does equal 0 because that is a point. Let me do one more. If we answer all the same questions for x squared, which is this picture, what's the domain of that one? All real numbers. Doesn't this go all the way that way and all the way that way? Doesn't it keep on going? Yep. So we've got one that has a domain of all real numbers. We've got one that has a domain of everything bigger than 0 and then everything bigger than or equal to 0. Okay, so what's the range of these things? Well, look at the y's in this picture. What are the y's doing there? Greater than or equal to 0. What about these y's though? What's going on with these y's?
They can't equal 0.
All reals. That's all reals. Right there, y equals 0, right there at that point. So that goes up and down all the way. The range is all the y's, up and down. When you're asking yourself about range, you're saying, how high do the y's go? How low do the y's go? What about the range here? Y is greater than or equal to 0. Alright, what about asymptotes? Does this curve have any asymptotes? No. Does this curve have any asymptotes?
Yes.
Yes. X equals 0 is an asymptote. Does this one have any asymptotes? No, there's no asymptotes in that picture. No. Increasing or decreasing? Remember when you ask that question, you're moving left to right. So is this guy increasing or decreasing? Increasing on the whole interval. Increasing on the whole interval. What about this guy, left to right? Increasing on the whole interval. What about this guy, left to right? What's it doing till it gets to 0? Decreasing. And then it is increasing. So this one is decreasing from negative infinity to 0, but it's increasing from 0 to positive infinity. And finally, bounded. Now remember, bounded below means you have a floor. Bounded above means you have a ceiling. Bounded both means you have a floor and a ceiling. So a bounded at both, it would be like your sine curve. Remember your sine curve? That's bounded above and below. It has a floor and a ceiling. Does this one have a floor or a ceiling? Has a floor. So this one's bounded below at 0. Bounded right there. It's got a floor at 0. Doesn't go past 0. What about this one? Is this one bounded? No, it's not bounded above or below. So this one is not bounded at all. It goes up forever and it goes down forever. What about this one?
Below.
This one's bounded below, just like that one. At y, or at, y equals 0. Right here. Right? Olivia?
If it was upside down, would it be above?
Mm-hmm. Now, one more comment about this. When we say the domain is greater than 0, for example, remember, if this is a multiple choice question, that concept, x greater than 0, could also be written like this. You've got to be cognizant of interval notation. Remember, our exam is shared. A lot of the questions are shared. And the honors and academic kids spend a lot more time with interval notation than we do. So I've been fine with x greater than 0, but those teachers want interval notation for everything, so they would express it this way. Okay, so pay attention to that. Interval notation.
What's one of them that would be bounded above and below?
Sine curve.
Oh, okay, sorry, yeah.
What's my personal least favorite BFF? Anybody happen to remember? I know I told you because I always brag on it. I hate the greatest integer function. It's not on the exam, don't worry about it.
That's
I
one where
hate
it's
it.
like a line and then a line.
It's a step function. All right, what else?
The I.
What?
The I.
I's?
Yeah,
What about them?
Like, can you do one?
Like what kind of
3
problem?
minus I.
Imaginary number?
Yeah.
So, like multiply two of them together?
Like, yeah, you have to FOIL the I's.
So like 3 minus I and 5 plus 2I?
Yeah.
So you said already, you already told me how to do it, you FOIL it. When you have to multiply two complex numbers, like these two, you just FOIL them. So you have first, so first would be 15, outside would be 6I, inside would be negative 5I, and last would be negative 2I squared. So I'm just straightforward, first outside, inside, last. Right? Now, let's start cleaning things up. These guys are like terms. So they're going to add together and make 1i. I squared is -1. So this -2 times I squared is actually going to be +2. But I got a 15, so it's actually going to be 17 plus I. Right? All right, what else?
You do one where you define it. You define the eyes.
Is there one on the review sheet? Please be choosing problems from the review sheet, guys. So I'll go ahead and do it. I don't remember one of these being on the review sheet, but I'll go ahead and do it. What do we do? You gotta multiply the top and the bottom by the conjugate of the bottom. And the conjugate means we just change the middle sign. So we multiply the top and the bottom by the conjugate of the bottom. And then we just start foiling like we did over here. So 20 minus 8i minus 15i plus 6i squared. And 25 minus 10i plus 10i minus 4i squared. What's this? -6. So that's going to be a 14 minus 23i on top. These cancel. What's that?
4.
Plus 4. So 29 on the bottom, and there would be my answer.
Are we going to be getting any equations on this?
Huh?
Are we going to get any equations on this? Like the first one?
I'm giving you both growth equations, because I wussed out completely and just wrote them on the cover. I shouldn't have, but I did. So I'm giving you I'm giving you the PERT formula and the other one. James Wayne?
Can you do where it says use interval notation to list the intervals where the function is increasing or decreasing?
So it's sort of like what we were talking about a minute ago, except the function is not like one of your BFFs, it's just some randomly drawn thing. So it's like this, just some shape, and we wanted to have the intervals, and it doesn't matter. Well, let's do decreasing intervals. We could do increasing or decreasing. Let's do decreasing. What that means is, as you draw this from the left to the right, so put your pencil right here and start drawing. Where are you going down? Decreasing means going down. So aren't we going down in this section and in this section? That's where we're going down? So you simply list the intervals. Those are the x values where we are decreasing. There's 2 of them. They're decreasing there and they're decreasing there. So we're looking at x values. Where do we start decreasing here? What's our x value? -3.
-1.
Where do we stop decreasing? X value, -1. Now where do we start decreasing again?
2.
2 and all the way to 4. So those are the intervals where my pencil is going down. I could just as easily do the ones where I'm going up. I'm going up from, let's see, what is this, -4 to -3. I'm going up. And then I'm going up again from -1 all the way to 2. Remember, I'm doing x values. When I write these intervals, it is x values. Going left to right, x's. All right, what else? Find the remainder. Yeah, the only thing you have to be careful about with a find the remainder problem is if you're using synthetic division, which I hope you are because it's so much easier, you got to make sure you don't have any powers missing. So, like if you had 3x cubed minus 8x plus 5, and you're dividing that by x minus 2, when you do your synthetic division, you're of course going to put a 2 out here in the box, right? Because it's always the opposite of your divisor, whatever you're dividing by. But be careful when you write down your coefficients. See how we have one missing? So you got to put a 0 in. If nothing's missing, then you don't put any zeros in, but just be aware that there might be something missing. Then we just divide. So we bring the 3 straight down, and then 2 times 3, add, 2 times 6, add, 2 times 4, add. So the remainder would be 13.
How would you write that? Just
It's going to be a multiple choice question, so he's got 13 in it. That's what you're going to go with.
So there's not going to be a question like, you know when we did those kind of graphs, and then we'd have to like inverse it, and there's not going to be a question like that.
Now, those ideas were in that problem I talked about earlier, where you had to build an equation that went 1 unit left and 2 units up or whatever. But you are not going to have to graph some random thing. You're going to have to do what's on the worksheet. James?
can you do a discount and tax off the original
Yep.
price?
This is going to be a calculator problem. This will be a free response, not multiple choice.
Is it mainly multiple choice?
About half and half. So, so let's say I buy something that costs $15.35, and it's on sale. There's a discount of, let's say, 18%, and there's a tax of 7%, and I want to know what the final cost is going to be. So I know I'm going to multiply. This is a multiplication problem. I'm going to start with my original price, and then I'm going to multiply by an 18% discount. So I'm going to subtract 18% and a 7% tax. So I'm going to add that on. And when I say I'm subtracting 18%, I'm subtracting it from 100. So 100 minus 18 is 0.82, and 100 plus 7 is 1.07. Then I just type those in and round it off to the nearest cent. And I got $13.47. That's what I'll pay when I get to the checkout. Okay? Anybody else? Every time you go shopping, you probably do something like this. I just did this the other day. My daughters, they're very different than me. A couple of them are, and they wear makeup and stuff. And of course they have to have this expensive makeup. I can't even believe a little bottle's like $40. So luckily I had a 20% off coupon. So I'm in the store picking up 2 of these little bottles, so it's $80 plus a couple other things. But my 20% off coupon, so in my mind I'm doing this math, trying to figure out if I'm gonna get out of there in less than $100 or not, and I did barely. Anyway, neither here nor there, but practical application, we all do this when we go shopping, unless we're just so rich we don't care. Anything else?
Oh, I have one. Find the asymptotes of f of x.
So we did problems where you had to graph everything. Remember, it had asymptotes and holes and intercepts and all that.
Yeah.
You're not doing that, but you're taking a picture that looks like that, like x plus 5 over x squared minus 8x plus 15. Oh, I don't need to, yeah, that's fine. 15?
Like a 0.
No. Yeah. Okay, something like that. And we're not graphing it and all that stuff, but you are asked for all the asymptotes. So that means you're going to have to find the vertical and the horizontal asymptotes. The horizontal one, remember, is easy because it's just a comparison of the powers. When the power on top is smaller, in other words, the power on the bottom is bigger, that means your asymptote is at 0. Your horizontal asymptote is at 0. If the power on top happened to be bigger, then you wouldn't even have one. If the powers match, so if this had been x squared plus 5 over x squared minus 8, then it would be 1. But they didn't match, the bottom was bigger, so that gives me a 0. Now the vertical asymptotes come where the denominator is 0. So I'm going to have to factor this, right? So I'll factor it. And my vertical asymptotes, there are 2 of them. One of them is at 5, and one of them is at 3. Vertical asymptotes come from the denominator being 0, and horizontal asymptotes come from comparing the fractions. The top and the bottom of the fraction. So a compound inequality. So 6 is less than or equal to 3x plus 2 is less than 7, something like that. You're just solving for x. So if you want to get x by itself, what do you need to do? Gotta subtract 2. So 4 is less than or equal to 3x is less than 5. Now we divide everything by 3. So 4/3 is less than or equal to x is less than 5/3. But be careful, that could be written like this, right? That would be the interval notation for that. Remember, the bracket is the or equal to, and the parentheses is the just plain, not just the plain inequality. Right? All right. So tomorrow we're going to come ready to rock and roll. But you can't leave yet. You've got 5 minutes. Please erase your desks and put the erasers and